All right, here's kind of the second part or first part or whatever of this linear and nonlinear um, lesson for the day. All right, we have these parent functions right here, and we have a function name. All right, if it's a constant, it's going to look like this, and it has a graph. Now it's going to go, it's a horizontal line, excuse me, that goes through that y value. Like this one is y equals 2. Okay, that's a constant. Uh, we won't see very many of these on the test and anything, but it's something we have to cover. All right, a regular linear, this is a regular line. It's diagonal. You should know it can go, this is going up or it can go down. Okay, typical the ones that you've graphed before, y equals x. And we're going to get a whole lot of that coming up in unit 4. All right, quadratic. You're going to get a lot of this in unit 9. This looks like a U. It has an axis of symmetry. Like here's its axis of symmetry right here. Also, something you need to know is that they can also open down like this. Okay. Just need to be able, a quadratic, it looks like a U can open up or down. Whoa, I did not mean to mark through that. All right, a square root function. I will tell you this is only the positive root. The reason why, if we were to actually, if we actually had to graph this, the reason these are two different functions is because if it looked like this, then it would not pass the vertical line test. So it looks kind of like half of U. Well, think about it. A quadratic is x squared. It looks like that. This is a square root, so it's kind of half of it laying down. We actually found the range of this. That's why the numbers look kind of weird earlier in the week, but that's okay. All right, absolute value. This is how I remember it. Absolute value. It looks like a V. Okay, it has an axis of symmetry also. And it can also open down, but it can also open down as a V. And they have a max and min and stuff. It depends on which way they open. Okay, so thing about absolute value is a V. All right, a cubic. Cubic. That's because it's x cubed. I always said it looks like a stretched out S. Some people said it looks like a little snake, a little slithery snake. All right, I just think it looks like somebody took an S and they just kind of stretched it out. Okay, that's just how I remember it in my mind. You may want to write something else to help you. All right, step function looks like stairs. Okay. Bloop, 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 bloop. All right, kind of a neat thing on step functions. You see that one of them is filled in, one of them is not. That's because if this one was filled in, it wouldn't be a function because it would fail the vertical line test. Okay, so you would always have, some of these values would overlap of the x, but there's an open circle, so I guess it's kind of like the cheat code to get by with that. All right, exponential looks like a ramp. It goes up. This one actually looks like this. This is kind of the function that we look at when we study exponentials. But it looks like a ramp. Believe it or not, it never touches. It always has like an asymptote. This will never get all the way, like it could be 0.00000000001, but it will never touch. This one will never touch the x-axis. All right, and that's just a brief little overview of the parent functions. You do have some of the questions on your homework today, and you'll have some on the test. So, and that's just kind of how it will go.